All right, well, hi guys. This worksheet is on page 15 in your Graphing Linear Equations packet, so I'm going to ask you to go to that page right now. And we are going to do a quick review and then some new information today to practice. So this on page 15 is just, again, solving for y and table graphing practice. So we have talked about how if a linear equation is in a form that's not y equals mx plus b, that we know how to put it into y equals mx plus b so that we could make a table like we're used to and we could graph it. So let's just do one real quick one just to remind ourselves of that, and I'm actually going to skip down all the way to number 4 on this page. So page 15, number 4. And let's see, this one is not in y equals mx plus b, so we are going to put it in y equals mx plus b by manipulating it, by doing things to both sides of the equation to try and get the y by itself. So what's in the way of having the y by itself? That x needs to go and the 3 times needs to go. So let's get rid of our x first, do our adding, subtracting first. Whatever we do to one side, we have to do the other. And by subtracting x, x minus x goes bye-bye. See ya. We bring down what's left. And over on this side, we can't combine the constants and the variable, so we just write them out the way they are. Negative 6 minus x becomes negative 6 minus x. We cannot combine them. They're not like terms. So we did talk about that we want to have y equals mx plus b eventually. We want to turn this subtraction into an adding, so we're going to change it to adding the opposite, so that becomes plus a negative x. That doesn't change the value. And now we've got one thing left to do to get the y by itself here, and that's to get rid of the 3 times. So to get rid of multiplying, we divide by 3. And the rule is that whatever we do to one side, we have to do to the other. So we're going to divide everything on this side by 3. 3 divided by 3 is just 1, leaves us with a y, equals, and over here, negative 6 divided by 3 is negative 2, no big deal, plus, and over here, this negative x is like a negative 1x. So when we divide, negative 1 divided by 3 just is negative 1 divided by 3, negative 1/3, and we have the x there. So now we're going to flip these around just so that we can put it in the official y equals something x plus something, y equals mx plus b formats. And I'm going to be careful when I flip them around not to lose the negatives that are on both of those right now. Alright, so there is our y equals mx plus b. Now, if we were doing this the way we normally been doing then, we put it in that format so that now we can make a table and we can look and we can see, is there going to be a pattern in our y's? We know that if our x's go up by 1, there will be a pattern in our y's. Let's try and make a table for this. The only downside is that this 1/3 in front of the x makes the table a little bit more difficult than if it were just whole numbers right there, right? And can you imagine some of the other ones we've done where we've had big time fractions in here, that it would definitely be a little bit more difficult to make a table for this. So let's go through this and then we'll talk about other strategies if the table isn't an easy table to make. So we're going to try our negative 1, 0, 1, and 2, and let's try plugging them in. Negative 1, I didn't leave myself very much room over here, so I'm going to do it down at the bottom. Y equals negative 1/3 times negative 1 plus negative 2. All right, negative times a negative, this is going to be a positive 1/3 plus negative 2. So can you imagine if you're down at negative 2 and you're adding a positive 1/3 to it, you're going to be at negative 1 now, because you were at negative 2. You've added a third, so now it's just negative 1 2/3, if you can visualize that. Or we could make those into fractions and find a common denominator and actually add them together. 0 is always the easiest one. Negative 1/3 times 0 plus negative 2. Negative 1/3 times 0 is just 0, plus negative 2 takes us to negative 2. Try negative 1/3 times, let's see, what are we plugging in now? 1 plus negative 2. In this case, negative 1/3 times 1 is negative 1/3 plus another negative 2. A negative plus another negative takes you more negative. Negative 2 1/3. And our last one, negative 1/3 times 2 plus negative 2. This is negative 2/3. All right, if we put this over 1, negative 2/3 plus a negative 2. So now we're going down negative plus a negative, negative 2 2/3. Do we see a pattern in our y's? We hope so. If the x's are going up by 1, the pattern we see in our y's should be this number in front of our x right here. So is our y value going down by a third every time? It's a negative 1/3. Does it go down by a third? Are we going down another third from here? Then we go down another third. Then we go down another third. Yes. So we can definitely see our pattern right there. And if we were to graph this, let's give it a try. We can estimate the best we can with 1/3 and 2/3 on the graph. Negative 1 for x, negative 1 2/3-ish for y. 0, negative 2 right here. 1, negative 2 1/3, and 2, negative 2 2/3, something like that. This is not a very steep line. There we go. And if we really were doing this, I would probably have us labeling all of the different ordered pairs on the graph. Negative 1 2/3. You guys would know how to do that and to continue that. So with this, we totally know how to make it happen. It's just that once we got to this step, it was a little bit of a slower process because of the fractions that were in here. So I want to give you another option that we haven't done yet for how to graph an equation that isn't in y equals mx plus b form first. So if you've got an equation where you've got the x's, some number of x's, plus some number of y's right here equals a number, and it's not in y equals mx plus b, there is another way we can do this by making a table a little bit differently, essentially, and not even putting it into y equals mx plus b form. So I'm going to show you that. The downside is, if it's not in y equals mx plus b and we're not making a table this way, we can't check our work to make sure we're seeing the right pattern. So we've got to be super careful with our negatives and positives to make sure that we're doing this the right way. So let's keep in mind that we know how to do this method, and we still will need to know that. But let's turn to the next page and see a secondary method, something we could choose if we think it would be easier. All right, so we're looking at page 16. This one says graphing using intercepts. So we want to talk about what these word intercepts mean right here. And let me show you. I'm going to put over here where you draw a quick little sketch of your x and y axis. Over here, we know this is the x-axis and this is the y-axis on a coordinate plane. If we have a line, I don't know, I'm going to make a new one like this. If we have a line really in any direction, it is going to hit the y-axis at some point. Right here. That's where it hits the y-axis, so we call this the y-intercept. It's where it intercepts the y-axis, kind of intersects it. All right, and then right here, this point on this graph would be where it hits the x-axis, so this would be its x-intercept. Intercept. There we go. So the theory is that if we can find where the line hits the x-axis and the y-axis, then we can put two dots there, connect the dots, and we've got a line. So in this case, we won't be finding 4 ordered pairs to graph it. We'll only be finding 2. And like I said, the danger is with only 2 ordered pairs, if we made a silly mistake with one and we got the wrong x-intercept right here, would we have a way to check it? Not really. So we've got to be super careful with our calculations for this. So we are going to learn how to find the x-intercept and the y-intercept and just graph from that. So for definitions, the x-intercept is the point where a line hits the x-axis. The point where a line hits the x-axis. Okay, so that's what it looks like on the graph, but in reality, every single point on a line is a what for the equation? Yeah, every single point on the line is a solution, right? So what does this particular solution mean? If it hits the x-axis, what would be the ordered pairs for that? It's going to be side to side something We don't know what that something is, side to side some amount of x, but are you going to go up or down at all? No, the up or down, the y, is going to be 0. So the x-intercept is something comma 0. It means the solution to the equation, the y is always going to be 0 for that particular solution. Right? So another thing I'm going to say about this is that the x-intercept is when y equals 0. So we're going to say when y equals 0. So that's going to be important to remember. The x-intercept is when y equals 0. So then for the y-intercept, it's going to be the opposite of that. The y-intercept is when x equals 0. This y-intercept point, you'd go side to side nothing and then just go up or down right here. So I'm going to put for our y-intercept, it's the point where a line hits, the y-intercept is the y-axis, and so our ordered pair is always going to be side to side 0 and then up or down to some y. And that happens when, which one is 0, the x or the y? When the x equals 0. So the x-intercept is when y equals 0, and the y-intercept is when x equals 0. So knowing that bit of information is all we need to know to be able to actually plug some things in to find these points. So let me show you on this example right here. It says find the x-intercept and the y-intercept of the graph of, and here is our linear equation. Is this one in y equals mx plus b? No, it's not, and that's okay, because actually to find the x and y-intercept, to use this method, it's way faster if it's not in y equals mx plus b. And actually, I'm not even going to use the work over here, the workspace for it. We're going to put our work here because we can do it a little bit more efficiently than they've got us doing over in this way. So I'm just going to write this equation again. 8x minus 2y equals 32. All right, our goal is to find 2 points where it hits the y-axis and where it hits the x-axis. So it doesn't matter which one we find first. I'll find the x-intercept first just because it comes first. So I'm going to have you guys write this out. The x-intercept, we're trying to find that first, is when y equals 0. Agreed? X-intercept up here is when y equals 0. So if y equals 0, can't we just plug in 0 into the equation and see what happens? All right, let's try that. If y, we know y equals 0, we still have 8x minus 2 times 0 now equals 32. All right, so let's simplify that. What is 2 times 0? Isn't that just 0? So 2 times 0 really makes this whole thing go away. It's really not there anymore because 2 times 0 is just 0. And all we have left is 8x equals 32. Well, if we know 8x equals 32, could we get what x equals? Yeah, we can get x by itself. Divide both sides by 8, and what does x equal? 32 divided by 8 is 4. So the point of that was we knew that y had to equal 0 for it to be an x-intercept. We just didn't know how far to move left or right for the x. So this tells us that when y is 0, x equals 4. So what is the actual solution? What is the ordered pair that goes with that? X comma y, 4 comma 0. So now we know that this is a point on our line. This is a solution that makes the equation true. And we could graph that, and it would be our x-intercept. So that is half of the problem. We've got our x-intercept. We just now have to find our y-intercept, and we'll be done. We'll be able to graph this. So the y-intercept is when what? The y-intercept is when x equals 0. So we're going to write that. Y-intercept, x equals 0. I'm going to write that out every time just so that we remember what part of the process we're on. And now let's write our equation again, but this time I'm going to use 8x minus 2y minus 32, and I'm going to plug in 0 for x. So 8 times 0 minus 2y equals 32. What's 8 times 0? Just 0. So this really is just 0. It goes away. And we're left with negative 2y equals 32. How do we get the y by itself? Divide both sides by negative 2. And you get that y equals a positive divided by a negative is a negative, and 32 divided by 2, 16. So what's our actual ordered pair? When x is 0, y is negative 16. And there we go. We've got two solutions to the equation. If we graphed these, we'd have two dots. We could connect the dots, and we would have our line, our linear equation that represents all the solutions for this guy right here. So we didn't have a graph for this one. We're going to graph it in a couple of examples here. But that is one example to start off with. These would be the two solutions that you found. Let's try looking at page 17 for some more examples. All right. Let's try, top of page 17, let's try number 2 with all these negatives, just all the way out here. Let's just do this work off to the side. So it was negative 12x minus 4y equals 36. Let's see if we can just do exactly what we did. We're trying to find two different things. We want the x-intercept, and then we want the y-intercept. So the x-intercept is when y equals 0. So we're going to plug in 0 for y and see what we get. Negative 12x minus 4 times 0 equals 36. Now you're going to start to see that essentially once you plug in 0, it's going to get rid of a whole term. Really, we're getting rid of all of this because the 4 times 0 was just 0. So you don't have to show this plug-in step right here if you realize that it just gets rid of this whole thing. Really, this is going to go away, and we've got negative 12x equals 36. That's what happens when we plug in y equals 0. So then it's just a quick division to get the x by itself. Divide both sides by negative 12, and you get x equals positive divided by a negative is a negative, and 36 divided by 12, what's that going to give us? Be negative 3. So what was the point of getting that x equaled negative 3? What's the actual solution, the whole ordered pair for this x-intercept? The x is negative 3 when the y is 0. So there's our x-intercept. And now let's find our y-intercept, and we'll have 2 points. We could graph them and we'd be done. So our y-intercept is when x equals 0. So we're going to plug in 0 for x way back here, and it would be negative 12 times 0 minus 4y equals 36. And the negative 12 times 0 is just 0. It goes away. So you're left with just negative 4y equals 36. Divide them both by negative 4, and you'll get your y by itself. And this time, it's going to be a negative, 36 divided by 4? It should be a negative 9 for us. So what was the ordered pair for this one? Okay, let's see, the x and the y. The x this time was 0, and the y was negative 9. So our x-intercept, side to side negative 3, up and down 0, and our y-intercept, side to side 0, down to negative 9. Can you picture what this would look like? I'm not going to do a perfect graph for this, but side to side negative 3 up or down 0 somewhere over here would be our x-intercept, and then side to side 0 down negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 somewhere down here, and we would be able to connect the dots, and that would be our line. Okay. So I think we're done with examples on this page. If you're stuck later on when you're doing practice for the homework or the checkpoint, come back and look at these examples that are on here. There's just one more thing to look at on page 18, and that would be if you are looking at an actual graph of the line. If they give you the graph but don't give you the equation, would you be able to identify the intercepts? So this should be a really quick thing. If we're looking here, where does this line cross the x-axis and the y-axis? Here's where it looks like it hits the x-axis. Here's where it looks like it hits the y-axis. Can we identify these as ordered pairs? I'm just going to put an arrow. What does this guy look like to us, this y-intercept? The y-intercept looks like side to side 0 up 2, 0, 2. There we go. And we know the y-intercept is always when x equals 0. And then this guy over here looks like our x-intercept, where it hits the x-axis side to side. So this one, starting from the origin, we'd go left to -2 first, but then we'd go up or down 0. So our x-intercept and our y-intercept, we just find their ordered pairs if we're looking at it on the graph and have to identify those. Okay, let's just have you do one more practice with that right down at the bottom. Can you go all the way to number 4 on page 18? Why don't you go ahead and pause this and try it yourself. Can you tell me what the x-intercept and the y-intercept are? And then you can come back and check it. All right, so our y-intercept is where it hits the y-axis right here, side to side 0, up to +3. And our x-intercept is where it hits the x-axis down here. This time it's side to side 1 and up or down 0. There's our x and y intercepts for this. Okay, so you have some practice. We are going to do page 19. If you take a look at this, this is going to be a bunch, 16 problems where you are going to plug in x equals 0 and then y equals 0 to find the y-intercept and the x-intercept. You are going to do that for all of these problems. There is no room to show your work on here, so you are not going to do it on this page. There's either a work page on the back or get a separate sheet and just tape or staple it in if you don't want to keep flipping. But I'm going to do the first problem with you just to remind you of how we're going to show our work for this. I do need to see all of the work. So let me see what that number 1 was. X plus y equals 4. Number 1, x plus y equals 4. The work that I would need to see would be something like this. The x-intercept is when y equals 0. So we're going to plug in 0 for y. X plus 0 equals 4. So all we get is that x equals 4. What is the ordered pair for that? Y was 0 and x was 4. 4, 0. And then if you want to, you could even just do a little line and you could put your other half of your work right here. The y-intercept is when x equals 0. So we're going to plug in x equals 0 and you get 0 plus y equals 4. This is a quicker example because there were no coefficients on the variables, so there was nothing we needed to divide by in this step. We just get y equals 4. So in this case, y equals 4. Our ordered pair is x is 0, y is 4. We get 4, 0 and 0, 4. So there's our work for this. And now on the graph with 4, 0 and 0, 4, we're going to go back and graph that. 4, 0, 1, 2, 3, 4. 0, 4, 1, 2, 3, 4. And we are going to connect those dots. And it is going to make a line that looks like it goes through this letter T. So our number 1 is going to be T. And we can go down to the bottom where we see number 1, and we can put in a T. And the answer to this is going to be, why did the rug roll up around his girlfriend? We will find out the answer to that guy. So you guys will do all your work on a separate page and then graph those ordered pairs when you get your x and y intercepts to do this. So it gives us another option. This may or may not be faster than actually just doing a table like we've been doing before and putting in -1, 0, 1, and 2. It really just depends on the equation. Oftentimes, when it's in this x and y on the same side of the equation form, this x and y intercept method is faster than putting it into y equals mx plus b and making a table. All right, I'm going to let you guys work on that and ask if you have any questions.